Assalamualaikum everyone, I am Afzal and today I am going to discuss the relational model in database management system. In this video I will discuss the relational models, the relational algebra which are applied and the relational model to store or to get or to manipulate some data. I will also discuss some type of relational models, and I will also discuss some SQL structures, some queries which we may apply on the data structure. When we talk about the relation, it means that we are actually talking about tables, that our data is actually stored in tables. Relational model means that our data is stored in tables. Okay. In relational data model, relations are saved in format of the tables as such like that. Okay, data is stored just like that. For example, if we are creating a table from the students, then the table name will be student and it will have some attributes. For example, the column name, which is the roll number, which is the name and phone number, etc. So the only one row in the table is called tuple. For example, we have stored the data of 100 students, but the data of only one student of Mr. A, his roll number, his name, his class, etc. Its detailed data from the column, from the table, is called a tuple. Relational instance actually define the set of tuples which exist in any particular relation in any particular table. And when we discuss the relational schema means that we are actually discussing the name of the table. We are also discussing the attributes of the table. Okay, when we discuss the name and attributes of the table, then this is called the relational schema. Relational key is you can say that this is a primary key which is used by the database engineer to identify any particular tuple, any particular row in the table or in the relations. Attribute domains describe the some predefined value scope of the domain. For example, if in the address, for example, we have the country, and in the country we have set domain that we can select only 3 countries. For example, we may select Pakistan, we may select Saudi Arabia, we may select Turkey, etc. So this is called the attribute domain. Relational integrity constraint discuss the constraints, the restrictions, the rules which we may apply on the relation. The first one is the key constraint. This discuss the constraints which are applied on the key and you may say on the primary key, which is used to uniquely identify our tuple. For example, we may say in every relation or in every table that the primary key must not be null. Okay, the primary key must not be null. The someone is domain constraint, as I just told you, that we put some constraint on the domain of some attributes. That, for example, we may put constraint on the age, that the for example, you are going toward the Nadra, where the citizens are registered, then only those person can get their registration card whose age is above 18. So this will be the domain constraints. Referential integrity constraints are associated on the relationship, that the constraints which are applied between the entity relationship is called the referential integrity constraints. Relational algebra actually discuss the algebra mathematical terms which are applied on the tables and the relations to populate data to show the data to the users, to the admins, etc. It is a language. It is a language to show the different type of queries which we apply on the tables. The first one is the select query. For example, you can say that here some thing is selected from the table books, okay, sorry, from the books table, where subject is a database and price is equal to 450. The project have different type of constraint. For example, here they are selecting something from the books, but they may constrain here on the subject and the author, and according to that the data is populated. Union combine two tables data. For example, here the data is combined from the book table relation and from the articles relations. Set different is also the algebraical term where the author who has written books but not included from the table article of the same author. Okay, it is just like a difference. You have studied that A difference B. Okay, constraint product show the books and articles of the author. Okay, and rename if you want to change some relationship, then we may apply these relational algebra on the different type of relations. Here model to relational model, here the relations model discuss the table and relational model discuss how data is represented. Actually, here we are mapping entity. We are showing the pictorial representation of an entity. And pictorial representation, you can see that this is a student. Student may have different type of attribute. For example, the roll number, his name, his class, and subject, etc. But you can see that the roll number is underlined. The roll number underline is showing that actually it is a key. Okay, it is a primary key which is used to uniquely identify any particular student, any particular tuple, any particular row from the table student. Here you can see that the relationship is shown in a pictorial formation. You can say this is the student, okay, and student have its own attributes, name and roll number, etc. And the roll number is showing that the roll number is the primary key of the student. We will use the roll number attribute to populate data from the student. And the second entity is the course. The second entity is the course. It has its course ID and title. The course ID is not underlined, but here in this pictorial format, the course ID will be its primary key. And the diamond sign shows that it has the relation. The student has relationship with course, and the relationship is enrollment. That student is enrolled for any particular course. So the association also have its own attributes that it discuss the marks of any particular student in that course, and it also discuss the joining date of the student in that particular course. Here you can see that the weak entity set up discussed. When we discuss the weak entity, then it means that weak entity is such like entity which doesn't have any primary key, which can be whose attributes may be, whose tuples may be identified uniquely. So here we assume that the dependent entity is weak. It doesn't have any key attribute to determine its attributes. And here you can see this is the student, and you also can see the student has roll number. The roll number is its key. We can use the student roll number to determine its name and its other attributes. So student is not a weak entity, but here in this position you can see that this is the dependent. The dependent key entity is also showed with double line. Okay, as you can see that this entity is also showed with double line, and the double line with the double line you also can see that it has only name and there is no other attribute which may use to determine to populate its data uniquely. So it is a weak entity. So this showed the dependent sign that this dependent entity actually depends on the student. Here the hierarchical entity mapping is shown here. For example, we are going to have a hierarchical to show the hierarchical position. When we go to show inheritance in programming or in the database, for example, here the person is shown. Here the person is. For example, here the person is shown. Okay. So the person has its attributes name. It also has age. Okay. It also has age. It also has its gender, age, and name. These are the attributes of the person. And the student and teacher is its specialization. Student and teacher is the specialized form of a person. So every student, when these are inherited from the person, it means that every attribute of the person are also inherited. So we add only the roll number to the students, and it also means that the students also having the name, the student is also having the age, student is also having the gender, because it is all the attributes of the person has been inherited. And the same things with the teacher, that it have its own employee ID and all the other data, for example name, for example the age, and the gender is inherited from the specialized entity, which is a person. Structure query language, we use the structure query language to create databases, to create a relation, the tables, and to insert some data. So the create database code to create, when we create any database or when tables, we use the create. And if you want to delete some database or any table, then we use the drop. And if you are going to change some data in the database, then we use the alter keyword. Data manipulation language may contain different type of commands. Select from where. We use the select to select data from particular table. For example, we can say select where id is equal to 100. We have to select those person whose id is equal to 100. From where we have to select. This shows that we have to from table is equal to employee. Table is equal to employee where. Okay, this will be written here. Okay, select from table. Okay, select name from table is equal to, for example, employee where id is equal to 100. And we want to insert data, then we may write insert into table, and we give the values of the exact tables, and update and delete also. These are also used to manipulate the data. As you can see that how the data is selected. Select author name. We are going to select the author name from book author. Okay, where age is greater than 50. We have to select the author name from the table book author, and the author, those authors whose age are 50, and we insert into table. Here we will write the table where we are going to insert the data, and what values we are going to insert will be written here. And if here we are going to update the table book, where the column, the attribute author is B, and where we have to change the author to A. So okay, this was little about the relational data model, the algebra which is used to represent different type of operations on the table and the databases, and also the structure query language which is used to change or to manipulate the data. Okay, thank you so much for watching.